Hi students, welcome back. So here we are for implicit functions differentiation. What do we mean by implicit functions? Again, in the functions chapter you can recall that the functions where x and y cannot be separated, those are known as implicit functions. So we are going to learn how to differentiate those functions. Again, it's not very difficult, but in this part I'm going to give a good trick which will directly help you in just writing the differentiation of those, how complex the function will be in just one step. Let's begin with this part. Let's begin the derivative of implicit functions. Okay, till now, whenever we were doing the differentiation, okay, whether it was logarithmic, whether it was chain rule, okay, in most of the question, in 90% of the question, I guess, except one example, in all the questions which we have done, y could have been expressed explicitly in terms of x. Means derivative was coming in terms of y, that's a different thing, but the function was separable initially. Means you can straightforwardly say y is a function of x. Okay. Now in implicit function, what is the case? It's a bit different. Okay, you cannot basically segregate x and y. Okay, so let's look at the definition first. That not the definition but a brief description. Okay, if x and y are related by the rule fxy. Okay, now here as you can see the first change is f of x and y. It's not fx or fy. Okay, why? Because it cannot be separated. For example, if I write x ln y is equal to sin y or sin xy. In no manner you can separate x and y exclusively. Okay, you cannot write f as x, f of y, or y as f of x. Okay, y cannot be obtained entirely or exactly in terms of x. Okay, then y is an implicit function of x. Okay, so we'll do an example and then I'll give you a shortcut trick for this. Okay, yeah, so log xy is equal to, now again here you can see that no matter whatever you do, you cannot separate x and y explicitly. Okay, you cannot write y is equal to f of something. Okay, so here same thing we are going to follow. Okay, now what's the difference here? Nothing. The things which we have discussed, one or two questions which we have taken, that thing I've already taken care of. Okay, so in this what you will do? Okay, first you will do the rule of, if I talk about left hand side, okay, first you will talk about the left hand side rule, the logarithmic differentiation, differentiation of log, not logarithmic differentiation. Okay, then product rule, xy, so x into dy by dx plus y, because dx by dx is 1. Okay, this is equal to 2x plus 2y dy by dx. Now this example perfectly display the thing which I was saying in the previous part, that this one and this one. Here dx by dx is there, but that does not appear. Why? Because it becomes 1, but y dash will appear. Okay, so ultimately you will club dy by dx together and all the other terms together. I'll do this. So this will be 1 by y dash plus 1 by x is equal to 2x plus 2y y dash. So y dash into 1 by y minus 2y is equal to 2x plus 1 by x, sorry, this will be minus, so this will come in the denominator itself. Okay, so this is again just no difference except that the function itself was in terms of x and y. Derivative it's coming in terms of x and y, but function itself is in terms of x and y. Okay, let us look at two examples more based on this. Okay, find the dy by dx. Okay, so before you continue with this, okay, you can pause and do it yourself and check after that whether I did it in the same way or something else. Okay, so in this one, what we will do, this is so easy, 1 plus y dash is equal to, now first we will do cos xy and then we will go for differentiation of this by product rule. Okay, so x y dash plus y. Now the things are so easy, 1 minus y cos xy. Okay, and this will be equal to y dash, if I keep here x cos xy minus 1. I bring this term here and the other part on the other side. So y dash becomes 1 minus cos xy over x cos xy minus 1. Okay, so this is how it goes. Okay, so again things becomes very easy now, as we can see that the terms in the previous slide also, if I go in the last step, as you can see, this was coming out to be here 1y over minus 2y. Now there is some kind of pattern here also. Okay, and when I wrote this one, there's some kind of pattern here also, again 1 minus something and similar kind of thing. Okay, so here's the trick that I'll discuss the trick after one more example. Okay, so it's given x square plus 2xy plus y cube is equal to 4. You have to find dy by dx. Again, simple. Okay, but this question, the difference is I'm going to use the trick. Okay, the trick says that you take all the things on one side, write that as 0. Okay, now straight away you can write dy by dx as, okay, minus. Okay, now if I take minus here, minus y cos xy minus 1, the things are looking in bit symmetry now. Okay, this thing and this thing. Okay, so what it basically becomes is that in the numerator we are differentiating with respect to x. Okay, whatever the function is. Okay, in this case the function will become x square plus 2xy plus y cube minus 4. Now once you differentiate with respect to x, and what you have to assume, y is a constant. That is the trick. In the numerator you say y is a constant. Okay, so this is 2x, y is constant, remember, so 2y plus y cube is 0 because it's a constant, we are treating it as a constant. 4 is again 0. Denominator will be keeping x as constant and differentiating with respect to y. Now with respect to y, this will be 0, this will be 2y because not 2y, sorry, 2x. Okay, so 2x will be here and then it will be y cube will be plus 3y square, and that will be 0. Now this is the direct formula. What I have said, make fx y equal to 0. Whatever the function is, take everything on the left hand side. Okay, then write dy by dx, and then what you have to do, this will be minus df of dx over df of dy. Now the assumption is that, not the assumption, but the trick is you have to keep y as a constant. Now this is not a trick, but from the pattern this has been observed, and from there you are saying, okay, this goes directly like this. So straight away I will write my dy by dx. Otherwise what you would have done, you would have differentiated with respect to x. So 2x, product rule here, 2 into x y dash plus y plus 3y cube y square, and then y dash equal to 0. Now y dash, with y dash, this 2x is there plus 3y square is there. This term you can take on this side, minus 2x minus 2y. Now this will come here. Now you can see that this is coming same as this one. Yes, I hope you agree with me and you will find, okay, this is so easy now. Yes, so this is the tricky part, that whenever you are having implicit function, this is you can always do. Okay, you can always follow this one when you are not able to separate. Directly do it. So this is a time saver in basically JEE Mains. Okay, in JEE Mains questions can be like this. Functions here I have taken easier so as to save the time and give more detailed on the concept. Okay, in JEE what will happen? It might be log x, e raised to power, something like that. So you have to keep in mind that the rule remains the same, the concept remains the same, and obviously as you will do the differentiation, the things which are now looking like a big huge task, okay, will just appear. Okay, this was hard once upon a time, how is it possible? So easy now. That will be your change, which will be there once you go through the complete section. I guess the illustrations which I have given were quite justifying the things which I talked earlier, and the trick given at the end must be very helpful when the questions in JEE Mains appear straightforward. So these are some tricks which you are gonna remember. And one thing more, like differentiation is all about practice. So I am doing here on my part, but that is not enough. That is enough to learn, but not to score. To get good scores, again you need to practice questions similar to that. So I am guessing on my part that you will be doing the needful on your side, and I will be doing the needful on my side. Stay tuned for the coming parts.